here, and what we're doing now is we're doing the review of the quiz that you guys took. Now, let me say something about the quiz. First of all, you had 8 problems on the quiz. That's not very many, the weight and balance problems. Second of all, you've done some of those before. Some of them should not have been new to you because we worked some of those in class as well. The next thing is that we spent 2.5 weeks covering how to use both the graph and the table method of what we do. And you've had videos to be able to go back and watch all of this stuff. So when I hear that there was a lack of effort on students' parts to even try to finish the quiz, I don't get that. I don't understand that at all. So, you know, it's one thing to perhaps not have done the homework, not have watched the videos, not have paid attention, but it's something else entirely to give up. Guys, if you start that now, if you start giving up now, you'll give up the rest of your lives. You can't do it. I'm not going to let you. You've got to try. You have to work it out. You've got to figure it out. You have all the materials. You have all of the videos. You have resources out the wazoo. To not try, that's pretty disappointing. So, let's not let that happen again. Can we make that deal? Is that a fair thing to ask? I hope so. Let's take a look and let's figure out these things. So, let's take a look at first of all, hand your paper to someone else. Hand your paper to the person next to you. I'll give you a second to go ahead and do that. Hand your papers to someone else. Mrs. Benton, please hand those out to the guys. I will rehydrate here. Okay. I do have my spectacles here because I will be looking at some of the things that are kind of tiny to see. So, first one that we look at, quiz question number 1. So when we look here at quiz question number 1, refer to figure 34. Refer to figure 34. Which figure is that? Well, is it this one? Is it the graph? Oh, look right there, figure 34. Excellent. What do we remember about this particular figure? Well, first of all, we have a moment here. Our index is 1,000, so we have a moment index with 1,000. Next, we have an oil issue here. So remember, 8 quarts of oil, that's 2 gallons, is 15 pounds, and it gives us a moment here of a negative 0.2. The empty weight of this aircraft does not include the weight of the oil. So remember, you've got to add that in. Then we have, basically, it is our loading envelope here of this airplane. We know that the max weight of this airplane is going to be 2,300 pounds because that's where everything stops right here. We also have 2 different categories. We have a utility category when the airplane is loaded lightly, and then we have a normal category for basically everything else. So along the left edge here vertically, you have all of your weight. Then going here from left to right is where you have your moment. So remember, the way that we use this graph is we find the weight here of whatever item that it's going to be. In this case, let's call it the pilot and front passenger. Let's say it's 300 pounds. You find 300, you come across the line here horizontally until you intersect with the angle here that represents the arm, And then from here, you come straight down using your plotter to draw a nice straight line. And then you find your load moment here. So if we look there, we know that there's 10, 11, that looks like 11.5 because two of these little lines equals one complete number. So here's 10.5, 11, 11.5, yada, 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 all along here. The next thing to remember is that you have two different fuel capacities that you have. One is the standard tanks, two is the long range tanks. One asterisk here is going to be the standard tanks, two asterisks here is going to be the load, the long range tanks, which, 10 gallons more of fuel. So that's kind of what we have here. And there are really only four things that you're working with: front seat, fuel, back seat, baggage, or a passenger here on the child seat, whatever that's going to be, with those limits. So that's the airplane that we're working on. So if we look at this, very first thing that you're going to do before you start anything is to do your table. So this is what you're going to do to start everything out with, correct? So now let's read the problem together, calculate the moment, okay, and determine which category is applicable. So what we're solving for here is going to be the moment of the aircraft and which category it's going to be. So let's take a look at what they give us. They give us the empty weight. So the empty weight, of course, that's what you're going to put here on your top line. So there's your empty weight. And you guys, you can fill this out. I'm sure you've done this. So if you look there at your empty weight, and I'm reading here, is that you've got 1,350 pounds. You've got it also in the front seat, 310, rear seat, 96, fuel, 38 gallons. How much is fuel? 38 gallons. Let me go back over here to this question. 3670, stand by. With this, so with 38 gallons of fuel right there, no, is that right? No, hang on. Fuel, 38 gallons, 38, I believe that's 228. 38 times 6. 38 times 6, let's say 48. There's the 8, carry the 4. And then we've got 36, 12, 14, yes, 228. 228 is going to be the weight there for your fuel. Oil weighs 15 pounds. So what did you get from the total weight column of this? In that total weight column, you should have gotten 1,999 pounds. Again. I say again because we did this problem in class. So 1,998 pounds. Next, we look at your moment. Now I'm going to read you again here what you should have gotten, or pretty darn close to it. So the basic empty weight of the airplane, 51.5. That's a given. 51.5 is the moment there of the airplane. Then 11.5 on the front seat. 7.0 rear passenger, fuel 11.0, oil minus 0.2, you should have gotten 80.8. 80.8. That's what you should have gotten. So when you look down here at this, whoops, not this one, this one. So when you look down here, 80.8, you have 80. Here's 80.5 right there. No, that's 81, 82, 83, 84, 85. So that line, so it's just inside this line right here. And you bring that up to 1,999 pounds. Guess where your little dot goes? Yep, right there. So what do you got? What you have there is that you have a moment of 80.8, which is what you were asked to find, and identified the category. In this case, it is just barely in the utility category. Just barely. So that's the answer to the question. 80.8 and utility. Next, we'll take a look here. Refer to figure 34, same deal. What is the maximum amount of fuel that may be on board the airplane on takeoff if loaded as follows. So again, with that, first thing you're going to do is you're going to put your graph out, your table out there, get everything ready to go. You know what goes in the top line, right? Your basic empty weight, because it's given, okay? Then we look down here, so we have 1350 in the empty weight, front seat 340, rear seat 310, baggage 45, and then we have oil, 8 quarts, got to add 15 pounds to that, right? Okay, so we look at that. And what do you get when you add all of that up? So you add everything up that is the known, because what we're solving for is we're solving for what's the maximum amount of fuel that we can put on this airplane if it's loaded as follows. And guys, this is a real world example of the calculations that you're going to do in the airplanes, because you got to know, okay, if I plan on putting this many people in this airplane, how much fuel can I carry? This is real world stuff. So we look at that. You should have gotten 2,060. Let me double check that and make sure. Give me just a second. 2,060, yes. 2,060 pounds is what you should have gotten there with that addition of your weight column. Now, what's the max takeoff weight of this airplane? 2,300 pounds. So what's the difference between 2,300 pounds and what you have right now of 2,060? So you take 2,300, subtract 2,060, what do you get? You get a range here of 240 pounds to play with. So you can play with 240 pounds. Just out of curiosity, I wonder how many gallons of fuel that is. 240 divided by 6 gives you what? Well, it looks like 40 gallons. Let's see if that works. So you plug 40 gallons of fuel in the fuel line, no pun, and then you check the moment. So when you look at that moment there with 40 gallons of fuel, that adds an additional moment of 11.5. So let's see if all of that works. So if you look at your moment side, you've got 51.5 for the airplane, which was given. Front seat, 12.6. Rear passenger, 22.6. Baggage, 4.2. And then the oil at a minus 0.2. Then you have to make sure that you add that fuel back in there, that moment of 11.5 for 40 gallons of fuel at 11.5. So when you look at that, I did this earlier here, maximum amount, so 240, yes, that's right. That puts you at 2,300 pounds right there, and it gives you a moment. Then if you add the moment column together, you should got something right at 102.2. 102.2. So if you look at that, and you'll see that's in the normal category, 102.2 at 2,300. So where that puts it, oops, this one, 102.2, there's that 102. So it'll put it somewhere about right there, okay? I don't have the ability to draw a straight line there, guys. So somewhere right there. So that's going to be 2,300 pounds, and we've got 102.2. We good to go, right? That is correct. Let's look at the next one. The next one is, and again refer to figure 34, determine the aircraft loaded moment and aircraft category. So we need to know we're solving for the moment and we're solving for the aircraft category. So you start with your table like always, empty weight of 1350, moment of 51.5 with the index of 1,000. Front seat passenger 380 from the front seat. Fuel, you have 48 gallons. How much does that weigh? Huh? The fuel here, 36.73, stand by. The fuel here, 288 gallons. 288 gallons, right, for your fuel. And then you have your oil at 15. What do you get for your total weight? Your total weight there, with adding all of that stuff up, should have been 2,033 pounds. 2,033 pounds. I'm looking at this based on the math that I did earlier. Okay, so now we want to make sure that we know what our moment is, right? Because we've been asked here to look at the loaded moment and which category it comes out to be. 51.5 is the moment here for the basic empty weight of the airplane. Front seat 14.0. Fuel 13.8. Oil negative 0.2 gives us a moment of 79.1. 79.1. So we look at 79.1. Here is 79.1 right here. We come up this line to, what was the number? 2,033 pounds. Here's 2,000, 20, 40, 60, 80. So it's going to be right about there. Right there. So that is your weight. That puts your moment right there at 79.1. So that is the normal category. So the moment, 79.1, category is normal. That is the answer to the question. Okay, let's look at one more. I think we have one more on the graph. Question number 4, determine the moment with the following data. So again, we have the empty weight, 1350, front seat, 340, fuel, standard tanks, capacity. So you got to know what the standard tanks are. So when you look at that, remember, you got to come over here. Here's your standard tanks right there, that asterisk, 38 gallons, right? That's standard. So when we look at that, let me find the question again, 35, 30. So we have 38 gallons. So that's 228 pounds, 228 pounds for fuel. Oil is 15 pounds. So what do we get here for our weight? Our total weight of this one, let me find this here, guys. Let me look. Question number 3672. No, 3672. Where is it? Where is it? Where is it? Here. Okay. So 1350, 340, 228, 15, that's going to be 1,933, right? 1,933 is the weight. And then for the moment, 51.5, which is, that's a given. 12.6 for the front seat. Fuel, 11.0. Oil, minus 0.2, gives us a moment of 74.9. That is what I got right here, 74.9. Okay? Determine the moment with the following data. And that's what we got, is a moment of 74.9. 74.9. And also, just know it didn't ask for this, but if we looked at this, 1933, here's 1933 coming across here. We said our moment was 74.9. Let's call it 75. That puts it right there inside the utility category, just to kind of finish things off there. So that's how we do that. So those were the 4 that were part of the graph part. Now the next part is the table. The table is the easy part, because when you look at the table, remember the table that you draw here, this is your table? Well, when you look at the table of the other ones here, this is, you basically, all you're doing is you're transferring data from one table to the next. So here's the table that you're using here, because remember, weight times arm equals moment. Weight times arm equals moment, right? So we look here, here's our weight times the arm equals moment. And we have an index here now of moment divided by 100. So the index is 100. So we take whatever the weight is at whatever station that we're talking about here. Remember, these are stations. The weight times the arm equals the moment. So we actually are able now to work with the real numbers, which this is great. Now we don't have to really decide, you know, how straight of a line can I draw? So we're looking at this. So let's take a look at the first one. The first one that we're looking at here, 3655. These are just my internal numbers. Here, guys, let me go back to this. 3655, is that right? Yes, 3655. So refer to figures 32 and 33. That's the table. Okay, 32 and 33. Determine if the airplane weight and balance is within limits. Weight and balance, are they within limits? Isn't that why we're here? Yeah. So let's look at this. So what was given is the front seat, which is the weight of 340, rear seat weight 295, fuel in the mains 44 gallons, right? And then the baggage of 56 pounds. That's what we're working with. Well, what's missing? Well, the very first thing should be the weight of the airplane, right? So remember where we find that. The weight of the airplane is given right here. This is where it tells us what the empty weight of the airplane is. It also tells us what the moment of that airplane is. We don't need the arm because it gave us the moment. Also, take a look here. The oil, it's included in the basic empty weight of this particular problem. So we don't have to factor in the oil on this one. And this gives us the outline of where we're going to be at what? Our max takeoff right here, 2950. That's what establishes our max takeoff weight, 2,950 pounds. Okay? All of that information is given to us right here. Right? So when we look here, let me go back to this. Let's look at the, because remember, you got to get this drawn. So check this out. Make sure that that's on there. And then we're going to look here. Give me just a second. 5 with the weight here. So with the weight, we should have gotten 2,015 pounds for the airplane, 340 for the front seat, 295 for the rear seat. 44 gallons times 6 is 264. 264 pounds, baggage 56 pounds. We should have gotten 2,970 pounds. 2,970 pounds. Ding, 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 ding. What do we know right here? That's our max. So we know right up front we have a problem. The problem is we're 20 pounds overweight. Okay, we're 20 pounds over. So we know that right up front. But what about the moment? Do we still have a balance in here? Well, in order for us to look at that, we'll come down here and we're going to be looking at this. So when we go down and we add the moment of everything here, so you have the moment of the airplane, here the basic empty weight of 1,554.0. That again is given because it was given in the first part of the problem. Front seat 340. 340, stand by. So here we have, I'm going to change the color of this here. Front seat 340. Now we notice here that the front seat, it stops at 200 pounds in the front seat. We don't care because we know that the weight here is 340 times the arm of 85, and that equals 289. Well, you're going to also, remember, you divide this by 100, right? And that's going to give you 289.0. 289.0 is the moment. Now, what about the rear seats? Well, let's take a look at the rear. There's the arm of 121. The rear seat is 295. So we have 295 times, that's a times, 121 divided by 100. That gives us 357 357.0. See how we're doing this here? So there's that, 357.0. Fuel, 264 pounds times 75 divided by 100 gives us 198.0. This is your moment column. Baggage, 56 times 140. So here's 56 times 140 equals, divided by 100, 78.4. So if you look at this column, 1554.0 plus 289.0 plus 357.0 plus 198.0 plus 78.4 gives us a moment of 2,000, hang on here, 2,400, let me get down here, 2,476.4. 2,476.4. Look at your range right here. Even at this weight, you have a range of 2422 with a max being 2499. 2476 comes in here somewhere. So it is within the moment, the balance part. It is within the balance part. It's just 20 pounds overweight. So the weight is 20 pounds over, but it would be balanced even at that weight. So that's the answer to the question. With the answer to that question is it's 20 pounds overweight, but the CG is still within limits. Okay? So remember, this one is so easy to work with. This one of all of the figures for weight and balance is the easiest because it gives you everything that you need to know. Then you take the information that you get from here, weight times arm equals moment, and you simply add it here into your column where you have weight times arm equals moment. And then it's just addition, adding the weight to your total weight, adding the moment all the way down to your total moment. Guys, that's it. If you just keep your accounting in order, this really is pretty straightforward. So that's it. I mean, if this were really, really hard, I probably couldn't do it. So this is how we work it. Let's look at the next one. Next one, refer to figures 32 and 33. By the way, that's going to be the table again. What is the maximum amount of baggage that can be carried when the airplane is loaded as follows? What is the maximum amount of baggage? That's the part that you circle. This is what we're solving for. That can be carried when the airplane is loaded as follows. So let's look at the loading. So we look at the loading of the airplane. Front seat, 387. Remember, you're adding all of this here to your table. Front seat of 387, rear seat of 293, fuel of 35 gallons. Where's my question here? Fuel of 35 gallons, is that right? Fuel of 30, yes. Fuel of 35 gallons, okay? And 35 gallons, we know that 35 gallons, 35 times 6 is 210 pounds. So you add that in. So when you add the weights of your airplane, which is 2,015 pounds, remember. Front seat, 387. Rear seat, 293. Fuel, 210. You should get a total weight of 2,905 pounds. 2,905. Now let me ask you a question. What's your max takeoff weight on this airplane? 2,950. Right? 2,950 pounds. 2,950 minus 2,905 gives you what to play with there? 45 pounds, right? That's the difference between 2,950 and 2,905 is 45 pounds. Let's see if that works. So what you do is you add that 45 into a column here for your baggage, add that 45, check your tools here, because here's your baggage, there's your arm. 45 times 100 in this case is going to give you a moment of 63.0. 45 times 140 divided by 100 is going to give you 63.0. So now you add that to your total moment column. So with your total moment, you got 1554 for the airplane, you've got 329.0 for the front seat, 354.5 for the rear seat, 157.5 for the fuel, and you have 63 for the baggage now, and that should give you a total moment of 2458. So you have 2,950 pounds now by adding that 45 pounds of baggage, and you have the moment here of 2,458. So does that compute? Let's find out. 2950? Check. That works. I need to be between the 2,422 and 2,499. It shows that I'm right here at 2,458. Yep, I'm in there. So with this, 45 pounds works, the moment works. I can add 45 pounds of baggage to this airplane, given all the other information that I have, and still fly it. There we go. That's that problem. Okay, so let's look at the next one. So on the next one, 367, this is this one here. Refer to figures 32 and 33. Duh. Calculate the weight and balance and determine if the CG and the weight of the airplane are within limits. So is my airplane within weight limits? Is my CG within limits? We got to figure that out. So we look at this again, you start here. And you always know that with this particular airplane on this particular figure of 32 and 33, you know that your airplane weighs 2,015 pounds and you have a moment of 1,554 with the index. So you put all of that stuff here. Front seat 350, rear seat 325, baggage 27, fuel, you've got 35 gallons, 35 times 6 is 210, right? So we look at that. That gives you a weight in your weight column here of 2,927 pounds. 2,927 pounds. So what do we know about that? Well, it looks like it's 23 pounds to the good. So it's within, by 23 pounds, our max weight of 2,950, right? So we're good so far. Then we look at this and we say, okay, what about the CG? So we look at the moment column. On the moment column, what you should put over there under the moment column, 1554 for the airplane, 297.5 for the front seat, 393.3 for the rear, 37.8 for the baggage, 157.5 for the fuel. That gives us a total of 2,440.1 if we, there for the moment, okay? But now it's asking us for the CG. Remember what we have to have for the CG. So to get our CG, we need to have total moment divided by total weight. So our total moment, we said, was 2440.1. Well, if you do all of the numbers out here like this, that's going to be 2440100, no, that one right there. 244,010 divided by 2927 is our weight. That's our moment. And with this, let me do the multiplication here. Say 27 here with this. See, 27 divided by 95. I get 83.4. 83.4. Okay, 83.4 is our CG. That is total moment divided by total weight equals the arm, or CG, right? So what does that mean? Well, if I look here at figure 33 here at the bottom, it's just giving me the moment side of things. I need to know about the CG. Gee, I wonder where I can find that. Oh, would you look at this? CG, right there. Okay? So, with this weight of 2,927 pounds, we have our CG here is 83.4. Is that between these limits? Yes, it is. It fits right there. So the weight is okay at 29.27, and our CG is good at 83.4. And the way that they will describe that is they'll say it's 83.4 inches aft, AFT, of datum. So wherever your datum plane is over here, adding it over here to this side, or actually I guess from the way you guys are looking at this, I should go over here. Coming this way to the airplane, that's what we're looking at. So 83.4 inches aft of datum, and we have seen here that this does work. Okay, there's that one. Last one. So the last one here is, refer to figure 32 and 33, yawn. Which action can adjust the airplane's weight to maximum gross weight and the CG within limits for takeoff? I wanted you to show your work on all of these, but specifically on this one. And the reason being is because I gave you on this what the FAA options are for you to do this problem. The reason I put this on here with the options is because it made it a little bit easier for you to do this problem, okay? So if we look at it, let's look at this again. You have the front seat 425, rear seat 300. Again, guys, you're putting all of this stuff in here. Fuel on your mains, 44 gallons. So if you look at this, let me turn here, it's on one of these here. So the weight of the airplane, you can put this in here, the empty weight of the airplane, 215, front seat, 425, rear seat, 300, fuel, 44 gallons, times 6 is going to be 264, correct? 264. And that leaves a total of 3,004 pounds. So our weight right there is 3,004 pounds. Ding, 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 ding. What can be the max takeoff weight of our airplane? 2,950. We're at 3,004 pounds. We're over, right? By how much? 54 pounds, right? You're 54 pounds. That's the difference. 3,050 minus 29. I'm sorry, 3,000. What did I say? 3,004? What did I say? 3,004? Yes. Sorry. 3,004 pounds minus 2,950 pounds gives you a difference of 54 pounds. So you're 54 pounds overweight. So what do you do to get the airplane where you can fly it? You know, within weight and balance limitations. Somehow you got to get rid of 54 pounds. So look at the options that you had available to you. Drain 12 gallons of fuel, drain 9 gallons of fuel, transfer 12 gallons of fuel from the main to the aux tanks. Now, here's a way that you can do this problem. First of all, you can plug and chug and you can try all three and see what you get. But here's a better way to think about this. 54 pounds, 54. If I'm looking at something and two of these options ask me to do something about draining fuel, I might want to think, could that work? How do you check? Take 54, divide it by 6. What do you get? 54 divided by 6. 54 pounds divided by 1 gallon of fuel. Okay? You get 9 gallons, right? Ding, 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 ding. 9 gallons of fuel. Hey, that looks like it may be one of the options that I have here for me, right? Let's see if that one works. So what you do is you plug that 9 gallons of fuel reduction, you pull that off, and so instead of the 44 gallons of fuel, you take that 9 gallons off and you get 35 gallons of fuel. Let me make sure I'm looking at the right problem here. 39 gallons, yes, 9 gallons minus 54. So if you do that, and so what you have to do then is to also calculate what moment that is. Well, if you look at this and you have done the moment on all of the problems up here before, you will see that the moment here of 1554, that's the airplane, 361.3 for the front seat, 363.0 for the rear. The fuel that you had on there, 44 gallons to start with, that one is 198.0, and that gives you a total moment of 2476.3, 2476.3. But we know that the weight is 54 pounds over. So we have to make an adjustment to that fuel line. To do that, we take 35 gallons instead of 44 gallons, and we look at what's the moment there of that. Well, you can do it that way and subtract the difference, or you can look and say, okay, what's the moment of 9 gallons of fuel? And you can do that because you can look right here and say, okay, here we are. If it's main right here, 9 gallons of fuel, 9 times 75 divided by 100 is 40.5. So what you can do is you can take 40.5 off your moment column, 40.5, which is that moment for that fuel. Subtract 40.5 from that, and that gives you 2435.8. 2535.8. Okay? So if you look then at 2435.8, does that work for us? 2435.8. Yep, falls within this line right there. So we subtracted 9 gallons of fuel to give us 35 gallons of fuel, and with making that adjustment, that still puts us here within the fore and aft CG range of our moment. We are good to go. There it is. Once you get the hang of it, it is basic addition, subtraction, multiplication, and division. Guys, it's 4th and 5th grade stuff right here. The key to everything is organizing your work. If you are trying to do this in some other way than using this particular table to keep all of your accounting in order, it doesn't matter what your conceptual basis of everything is. You're going to screw the numbers up. So keep your numbers clean. Using this, the table method versus the graph method, that is by far my favorite way to do things. But you got to know how to do both. So that's where we are, okay? So that ends that. Now, if you are not happy with your quiz, oops, hang on. Wow. Yes, my son is trying to contact me here. Ask yourself why. Why were you not happy with the outcome of your quiz? Was it effort? Was it a lack of understanding? Why was it a lack of understanding? Did the effort tie into your lack of understanding? All of these classes are recorded, guys. You can always go back and re-watch a class. That's the benefit of what we do here, is so that you can look at it if you're confused. You also have the books, so you can read the books and understand this. Then you can always send me a text. You can always send me an email. It's great if you want to come find me and ask me for help. That's awesome. But I'm not doing the work for you. You've got to show me your effort. Okay? That's what you have to show me. If you show me your effort and you still can't get it, I'll crawl through broken glass to get you to the finish line. But if you just come in expecting me to do it for you, that's not going to work for either one of us. Remember that sign that's over there on the side of that door in the classroom? There's no spoon feeding here in this class. That's not what we do. You're expected to show a certain amount of initiative. Some of you that have done that, I'm sure were satisfied with your results. Others, maybe not so much. But you got to put in the effort, gentlemen. That's the bottom line. Now then, let's take a look at what's next. What's next is going to be more on aircraft performance. So now that we understand the weight and the balance things of our airplane, now we need to be able to in some way predict the performance of our aircraft, because there's going to be times that we want to take off, but then we think, okay, is the weather really going to allow us to do it? Is it too hot? Is it too windy? Is the runway wrong? You know, these are things that we have to determine. What about our fuel flow during cruise? Do I have enough fuel? What's my power settings? So these are things that we're going to be looking at when we look at performance. And with that, I am going to switch this over here to this. Hang on here for me, gentlemen. Let me get down here. I think this is it. Yeah, would you look at that? Aircraft performance. So, chapter 11. This is what I want you guys to start reading, is chapter 11, okay? Chapter 11 is going to start working us through aircraft performance. So let's just take a peek here at what we're doing. Some of this stuff is going to be a reminder of things that we have done before. First of all, notice that your performance section is going to be noted in your AFM and your POH. You found that out when you did the paperwork portion of the chapter, whichever chapter that was. Notice the review here of our atmosphere. Notice the review of our atmosphere. This is something that is huge. Remember the makeup of our air. 78% nitrogen, 21% oxygen, 0.9% argon, 0.1% everything else. That makes up our air. 78% nitrogen, 21% oxygen, 0.9% argon, and 0.1% pick a molecule, okay? Everything else. That is the air, that's the percentages of the air that we have available to us, okay? So, right? Then also remember, we have to start measuring somewhere. Sea level is always a pretty good place to start. So to find what we call an international standard atmosphere, some place where we can begin our measurements, we will begin at sea level. We will begin at 29.92 inches of mercury, and that comes out to a millibar equivalent of 1013.2, by the way, 1013.2, on a standard temperature day, which is 59 degrees Fahrenheit or 15 degrees Celsius. You writing that down? That is international standard atmosphere. Also remember this. For every 1,000 feet of altitude that we gain, we lose approximately an inch of pressure. We lose approximately 1 inch of mercury, 1 inch of pressure. And during a standard lapse rate, we lose 2 degrees Celsius per 1,000 feet. 2 degrees Celsius per 1,000 feet. So if we look at 8,000 feet, 8,000 feet is roughly about where Aspen is So if we look at 8,000 feet, we can see that we have actually a pressure on a standard day of 22.22, but we can also see that our standard temperature for that altitude is going to be almost -1 degree Celsius. So a standard day for us is going to be -1 degree Celsius, and that would give us an approximate pressure here, an actual pressure of 22.22 inches of mercury. Now, why is that important? Everything else is going to mean that if we have anything that is warmer than that, if we have anything there where the pressure differential is different than that, our airplane will not perform like it will on a standard day for us. So we know that we're going to have some type of performance degradation for any temperature and pressure that is going to be less than what you see here. Now that's like, wow, okay, so the warmer it gets in Aspen, the more performance I lose for my airplane. That's correct. And it's the reason why you have 3,000-foot runways at sea level and you have 8,000-foot runways at altitude, because you've got to have them. Remember what happens to the molecules as you go up from sea level. As your altitude increases, then what happens is those molecules can begin to spread. They spread out. They become fewer and further between. It's all about the molecule. That's correct. So we have to make sure that we account for the lack of molecular density that occurs from sea level to altitude, especially if we're operating in a high altitude situation to begin with, and then also when it starts to get warmer. Because when it gets warmer, what happens to those molecules? Well, they spread out even further. Remember, you have to have X number of molecules flowing over that wing to get it and keep it in the air. That means that your airplane at altitude has to work harder to generate that same type of molecular flow when those molecules are all spread out. It has to work harder than it does at sea level, where all the molecules live. That is where the molecules are most dense. That's where aircraft performance is the greatest. So changing of altitude, changing of temperature will have a negative effect on the performance of our aircraft. How much? What will it allow us to do? What will it not let us do? That's the whole point of this chapter, is to find out what can you do, and probably more importantly, what can't you do given current altitude and temperature settings. You also have to count on your fuel flow. It's the one area that we actually kind of gain something from altitude, is because of the fact that now that we don't have as many molecules that can get sucked into our engine. Remember that you have to have three things to keep an engine running. You got to have air, fuel, and spark. Well, when the air becomes less dense and the molecules that are coming into the air are fewer and further between, and you have less number of oxygen molecules, the percentage is the same. It's just that there's just not enough molecules. So when you have fewer oxygen molecules being able to be available for combustion, now you have to start reducing the amount of fuel that you allow into the engine, right? Remember that on systems? So you can actually run leaner up here and actually use less fuel. So that's one area where we actually gain something. Thank goodness, okay? So here's what I'm asking you to do. I want you guys to read here through on chapter 11. I want you to get through page Hang on here, boys. Let's find a good stopping point. I want you guys to read, let me go back up here. I want you guys to read right here just before angle of climb. Angle of climb, I want you to stop right there. Now, I'm not telling you you have to stop. If you want to choose and read more, that's great. But I want you to get to at least page 7, right up here to the point of angle of climb, okay? And then we're going to walk through this. I'm going to give you kind of a cursory explanation of what all of these charts mean, but I want to see if you guys can kind of figure that out on your own before we get there. So, read to page 7. Here, angle of climb. Now, you know how I like to make sure you have done the reading. Be ready. Okay? So, there you go. We'll pick this up with angle of climb in chapter 11, page 7 on our next class. Guys, I'll see you.